Hi, welcome everyone. My name is Sammy Khalife and I'm a postdoc at Cornell Tech.
My name is Josué Tonelli-Cueto, and I am postdoc at Johns Hopkins.
Today we will present our ICLR article about the expressivity of GNNs.
What do we mean by GNN in our work? We will mean a sum aggregation combination GNN. We mean we add the signals on the neighbors of the vertex, then we combine this sum with the signal of our vertex using a combination function, which is a neural network. And among the three main topics, expressivity, trainability, and generability, our question focuses on how does the activation function affect the expressivity of the GNN?
In order to answer this question, we need to have a look at the target space formed of queries. For example, the query Q asks whether the vertex V has only neighbors that have degree at least 2. This query can be made a little bit more complicated by adding color attributes, red and blue here, such that Q tilde asks whether the vertex V has color red and has all of its neighbors blue and have only red neighbors. Q and Q tilde take concrete values on graph structures. For example, on the following graph structure for the vertex on top, Q will take value 1, so QS equals 1, because S has only neighbors of degree at least 2. But on X, Q will take value 0 because Q has a neighbor of degree 1. Q tilde, on the other hand, if I add some colors on the same graph, will take value 1 for S and 0 on a leaf, L here, because L has a neighbor that is red.
Now, the family of queries in which we will be focusing are the so-called GC2 queries. These queries are constructed starting first with the atomic queries that are the color predicates, and then we construct the GC2 queries out of this by using three construction rules. First one, if we negate a GC2 query, we have a new GC2 query. If we take the conjunction of two GC2 queries, then we have a new GC2 query. And finally, if we do a restricted quantification over the neighborhood of a vertex with a GC2 query, we get a new GC2 query.
Note that our two examples are GC2 queries because they can be formed as such.
What do we mean by expressing a GC2 query? We will be given a vertex and a graph. Then our GNN will produce a real number that is the output. And we want these real numbers to be well separated according to whether the query is true or false. Being more concrete, we want to find an epsilon such that the query is true if this output is above 1 minus epsilon, and that is false if this value is less or equal than epsilon.
We'll compare the expressivity of sigmoid GNNs to the expressivity of ReLU GNNs. The main known result about the expressivity of ReLU GNNs goes back to 2020 by Barcelo and co-authors, stating that for any GC2 query Q of size D, there is a ReLU GNN of size 4D that expresses Q over all graphs. In other words, ReLU GNN express GC2 queries uniformly. Conversely, if a ReLU GNN expresses a query that is of first order, then it has to be a GC2 query. In contrast, our first results state that this is not the case for sigmoid GNNs. If you consider our first example of query, then we can prove that for any sigmoid GNN and for any epsilon positive, there are three structures, T and T prime, and with roots S and S prime, such that the query takes value 1 on the first root and 0 on the second root, but such that the signal of the sigmoid GNN is less than epsilon, arbitrarily close, which proves that sigmoid GNNs cannot express uniformly GC2 queries.
However, not all are bad news, because if we are given a GC2 query Q of size D and a parameter delta that is positive, then we can construct a sigmoid GNN of size linear in D times log of delta, this parameter, that expresses Q over all graphs of degree at most delta. Since this dependency is so small on the size of the graph, we will say that sigmoid GNNs express almost uniformly GC2 queries. What's the take-home message of our paper? ReLU GNNs can express a GC2 query for all graphs in a way that the size of the GNN only depends on the query and not on the graph.
This situation does not happen for sigmoid GNNs, for which there exists GC2 queries where the size has to increase with the size of the input graph.
However, this increase is so small that doesn't have practical implications. Thanks a lot for your attention.
And please find all the details in our ICLR article. Thanks again.